Hi, today in Note 7, we're going to talk about functions. And one thing that you need to be aware of is it says right here at the top, these mathematical statements all mean the same thing. So if you see an equation that says y equals 2x plus 3, that's considered a linear equation because the x right here is understood to have an exponent of 1. So as long as basically you don't see an exponent, it's understood to be linear. Now then, other ways that you can see this linear function written could be f of x equals 2x plus 3, g of x equals 2x plus 3, h of a equals 2a plus 3. So whatever variable is in parentheses, that's the variable that needs to be in the expression to the right of the equal sign. So function notation. Function notation is basically when you transform the variable y to begin the equation and use any function. So f of x, g of x, h of a, that's called function notation. So on problems 1, 2, and 3, it says rewrite the given equations in correct function notation. So whatever variable you see in the equation, that's the variable that's going to go inside the parenthesis. And then all you have to do is copy the expression x plus 2. Problem 2. Again, whatever variable you have in that expression, that's the variable that's going to go in parentheses. And again, it really does not matter what the outside variable is. It can be f, it can be k, it can be a, it can be c, it doesn't matter. But again, the variable inside the parenthesis needs to be the same variable that's in that expression. And then you just copy this down of 3m plus 1. Number 3, so the outside variable is g. Again, that doesn't matter. But what does matter is that the c that's in that expression, negative 2c, is the same variable. And then we just copy negative 2c. So g of c is equal to negative 2c. All right, let's go on to completing some tables of values. So on problem 4, if we're going to complete the table of values, we have y is equal to 2x plus 1. Now, since we've been talking about function notation, another way to write this in function notation would be like f of x is equal to 2x plus 1. And again, nothing changes. You're still going to work it out. On problem 4, we're just going to find out what the y values are. So we're going to work it out just as if it were y equals 2x plus 1. So what we're going to do is we're going to plug in negative 1 in place of x. So it's going to look like 2 times negative 1 plus 1. So that's negative 2 plus 1, which is negative 1. And then we're going to put a 0 in place of x. 2 times 0 plus 1. So that'll give you 0 plus 1, which is 1. And then we're going to go 2 times 1 plus 1. So 2 times 1 is 2. Plus 1 gives us 3. And then we have 2 times 3 plus 1. And 2 times 3 is 6 plus 1, which gives us 7. All right, let's take a look at problem 5. Now we have y is equal to x plus 10. Another way to write this in function notation would be, we could go g of x is equal to x plus 10. And again, we're still going to treat it just like we do a regular equation beginning with y. Now then, on problem 5, you notice that the output is now given. So let's go ahead and practice with the 12. So if the input is X and the output is Y, that means we're going to replace the 12 with the Y. So it's going to look like this. I'm just going to start it up here. So it's going to look like 12 equals X plus 10. Now to solve this one-step equation, wouldn't we subtract 10 from both sides? So you're going to get X equals 12 minus 10 is 2. So 2 goes there. Now then, instead of working the one-step equation out for all of them, you know what we're going to have to do? We're going to have to subtract 10 from each Y value. So when we get to 8 here, so we're going to go 8 minus 10 gives us negative 2. So that's our X value there. So negative 2 plus 10 is 8. Then we're going to take negative 20 and subtract 10. So that will give us negative 30. And negative 30 plus 10 is negative 20. And then if we go 0 minus 10, that's going to give us a negative 10. And negative 10 plus 0 is negative 10. All right, let's see what we have down here now on domain and range. Some things to know about domain and range is that the domain represents the X value. So if you see right here, the domain represents the input, represents the X, and it's also the independent variable that we don't really have to go over this year. The range is going to be the output, the Y variable, and the dependent variable. So on number 6, when it says, given the set of points, what are the range values? So the range would be the Y values, 8, 15, and 9. Now, when we write these out, we're going to write them in numerical order from least to greatest. So I'm going to put 8, then 9, and then 15. On number 7, it says, given the set of points, what is the domain? The domain is the first number listed in each ordered pair. And if that's all 3s, we only have to write it down one time. You never repeat the domain or the range values. Only write it down one time. All right, let's go ahead and take a look at problem 8 on the back. For the following function, find the range values from the given domain values. So what we're going to do to get our negative 4 is we will go 1/2 times negative 4 plus 3. So half of negative 4 is negative 2 plus 3 is 1. And then we're going to go half, and you can always just put them in parentheses too. Half of negative 2 plus 3, that's negative 1 plus 3, which gives us 2. And then half of 0 plus 3. Well, half times 0, 0, 0 plus 3 is just going to give us 3. And then we have half of 2 plus 3. So half of 2 is 1 plus 3, which is 4. So let's see what they want us to finish writing out. So they want us to find the range. So the range would be 1, 2, 3, 4. And it's already in sequential order. So 1, 2, 3, and 4. All right, let's take a look at problem 9, the last problem here. It says, for the following function, find the domain value. So this is exactly what we did on the front, where we had to plug in our Y value. So over here, let me get some of these marks erased here. Oh, there we go. All right, so like if we're going to put negative 30 in place of f of x. Now remember, f of x is just the same thing as y. So we're going to put negative 30 in place of the f of x. So it would look like this. Negative 30 equals 5x. So what we're going to do is divide both sides by 5. So x equals negative 6. So instead of showing that on every one, you know what we're going to have to do? We're going to have to take every f of x value and divide it by 5. So we're going to take negative 20 divided by 5, and that will give us negative 4. Then we're going to take 10 divided by 5, and that will give us 2. And then we're going to take 15 divided by 5, and that will give us 3. So now when we write our domain values, we're going to write them in order from least to greatest, which they already are. So negative 6, negative 4, 2, and 3. So that's basically working with functions.